Journey with us as we dive deep into the mysteries of Neptune, the distant blue giant lurking in the outskirts of our solar system. 4 billion kilometers from the sun, this ice giant holds secrets yet to be fully understood. Today we're uncovering 10 fascinating facts about Neptune that will blow your mind. Prepare to have your perception of our cosmic neighborhood forever altered. Neptune's discovery is a testament to the power of human intellect and the elegance of mathematics. Unlike other planets found through observational astronomy, Neptune's existence was predicted before it was ever seen through a telescope. In the 1840s, astronomers noticed irregularities in Uranus's orbit, suggesting a gravitational tug from an unknown celestial body. Enter Urbain Le Verrier, a brilliant French mathematician who meticulously calculated the unseen planet's location using only the laws of gravity and the observed perturbations of Uranus. In 1846, based on Le Verrier's predictions, German astronomer Johann Galle pointed his telescope to the calculated coordinates and, to the astonishment of the scientific community, there it was, Neptune, a faint blue dot confirming the triumph of theoretical astronomy. This discovery marked a pivotal moment in our understanding of the cosmos, showcasing the predictive prowess of physics and forever linking Neptune with the power of mathematical reasoning. Imagine a planet where winds rage at supersonic speeds, making even the most ferocious hurricanes on Earth seem like gentle breezes. This is Neptune, the windiest planet in our solar system, a place where the very air itself whips around the planet at mind-boggling velocities. These winds, composed of hydrogen, helium, and methane, reach astonishing speeds of up to 2,100 kilometers per hour, creating colossal storms that dwarf our entire planet. The sheer force of these Neptunian winds is difficult to comprehend, driven by internal heat and the planet's rapid rotation. These winds play a crucial role in shaping Neptune's dynamic atmosphere, sculpting its cloud formations and influencing its overall weather patterns. Neptune, a majestic blue orb hanging in the inky blackness of space, captivates the imagination with its ethereal beauty. But what gives this distant giant its distinctive azure hue? The answer lies in the composition of its atmosphere, a turbulent mix of gases that absorb and reflect sunlight in fascinating ways. Methane, a gas present in Neptune's upper atmosphere, plays a crucial role in this celestial color show. This simple hydrocarbon molecule, composed of 1 carbon atom and 4 hydrogen atoms, efficiently absorbs red and infrared light from the sun, while allowing blue wavelengths to scatter back into space. This preferential absorption and scattering create the stunning blue we observe from Earth. Neptune's blue color is not static. It varies in intensity and shade depending on the altitude and composition of its atmospheric layers, adding another layer of intrigue to this enigmatic giant. In the heart of Neptune's turbulent atmosphere lies a captivating enigma, the Great Dark Spot, a swirling vortex of storm clouds that once rivaled Jupiter's Great Red Spot in size. This massive storm system, first observed by Voyager 2 in 1989, captivated astronomers with its sheer scale and power. The Great Dark Spot, a colossal anticyclone, spanned roughly 13,000 kilometers by 6,600 kilometers, large enough to engulf the entire Earth. Unlike Jupiter's more permanent storm, the Great Dark Spot proved to be a fleeting phenomenon. When the Hubble Space Telescope observed Neptune in 1994, the Great Dark Spot had vanished, leaving astronomers baffled. This disappearance highlighted the dynamic and ever-changing nature of Neptune's atmosphere, where storms can erupt, evolve, and dissipate on timescales far shorter than those on Earth. While not as prominent as Saturn's majestic rings, Neptune possesses its own system of faint, dusty rings that add to its allure. These rings, composed primarily of dust and small icy particles, were first discovered in 1984, not through direct observation, but by the subtle dimming of starlight as Neptune passed in front of distant stars. This discovery confirmed that rings are not unique to Saturn, but a common feature among the giant planets in our solar system. Voyager 2, during its historic flyby in 1989, provided the first detailed images of Neptune's rings, revealing their clumpy and uneven structure. These clumps, thought to be shepherded by the gravitational influence of small moons embedded within the rings, highlight the delicate balance of forces at play in these distant realms. Among Neptune's retinue of moons, Triton stands out as a true enigma, a celestial rebel that challenges our understanding of planetary systems. This icy moon, larger than the dwarf planet Pluto, orbits Neptune in the opposite direction of the planet's rotation, a phenomenon known as retrograde orbit. This peculiar orbital dance suggests that Triton may not have formed in orbit around Neptune, but was instead captured from the Kuiper Belt, a region of icy bodies beyond Pluto. Triton's surface is a testament to its dynamic past and present, sculpted by a combination of geological processes and cryovolcanism. Nitrogen ice, the dominant surface component, flows and erupts in geysers that spew plumes of nitrogen gas and dust kilometers high, painting the moon's surface with a surreal and ever-changing landscape. Neptune, like Earth, experiences seasons due to the tilt of its axis. However, the seasons on Neptune are far more extreme and prolonged, lasting for decades rather than months. Neptune's axis is tilted at an angle of 28 degrees relative to its orbit, a tilt similar to Earth's 23.5 degrees. This axial tilt means that Neptune's hemispheres receive varying amounts of sunlight throughout its long journey around the Sun. During its summer solstice, one hemisphere receives continuous sunlight for roughly 40 Earth years, while the other hemisphere experiences a long, dark winter. These extreme seasons drive dramatic changes in Neptune's atmospheric circulation patterns, potentially triggering massive storms and altering the planet's overall weather. Beneath Neptune's swirling blue atmosphere lies a mysterious interior, a place of immense pressure and exotic ices. Unlike the rocky terrestrial planets, Neptune lacks a well-defined solid surface. Instead, its atmosphere gradually transitions into a supercritical fluid, a state where the distinction between gas and liquid blurs. Deeper still, under crushing pressures thousands of times that of Earth's atmosphere, lies a mantle composed primarily of water, ammonia, and methane ices. These ices, however, are not like the familiar ice we know on Earth. Under the extreme conditions within Neptune, these ices are thought to exist in exotic, superionic states, conducting electricity like metals. Neptune's magnetic field, like its tilted axis and retrograde moon, presents another intriguing puzzle in our quest to understand this distant giant. Unlike Earth's magnetic field, which is generated by its molten iron core and aligns relatively closely with its axis of rotation, Neptune's magnetic field is significantly offset from its center and tilted at a dramatic angle to its rotation axis. This unusual configuration suggests that Neptune's magnetic field is generated not in its core, but in a layer of electrically conductive fluid, possibly a mixture of water, ammonia, and methane ices, located at shallower depths. This off-center tilted magnetic field creates a complex and dynamic magnetosphere, the region of space dominated by Neptune's magnetic field. Time on Neptune flows at a pace unimaginable to us Earthlings. A year on Neptune, the time it takes to complete one orbit around the Sun, is a staggering 165 Earth years. This means that since its discovery in 1846, Neptune has yet to complete a single orbit around the Sun. This immense orbital period is a consequence of Neptune's vast distance from the Sun. Orbiting at an average distance of 4.5 billion kilometers, Neptune receives far less solar energy than Earth, resulting in frigid temperatures and a slow, deliberate journey around our star. From its discovery through mathematical prediction to its supersonic winds and enigmatic rings, Neptune never ceases to amaze. We've explored its azure atmosphere, its fleeting storms, and the icy depths of its mysterious interior. Keep exploring the mysteries of our universe and stay curious. There's always something new to discover right here in our cosmic backyard. Until next time, keep looking up.